Hey, hello. Welcome to my laboratory 7. So this is all about debugging. So this is the objective. So first we analyze the broken round block. So here I already tested it, but this is my first time. So divide contains unwanted variable. So this one, it's talking about this one, which is not connected to 5. You have connected two terminals of different types. You have connected an output of add to a control. So let's see. You have connected an output of add to control, but this one is let me just check. So let's see. What's this one? Okay, so hold on a second. Let's try click running. So we fixed the one part. So I connected two terminals of different types. So let's see what will happen if I delete this one. Okay, so this one is two different types and output of add to a control. Change the control to an indicator. So that's simple. So let's right click this, change indicator. There. Okay, so we solved the two. So we have connected two terminals of different types. Okay, so we just need to change this into make time there. I think that's no, I think that's not it. Okay. Uh, control one. Don't save. Okay, so let's save this one. So this must be true or false. So we can change it. Indicator, data operations, advanced properties. I think the better way here is just to remove it and change to because I'm not really sure how to change this. Change description and tip. Okay, string arrays. It says it is not string. Number to string, string to number. Create data operation. Okay, so let me just delete this one and hope so that works. So let's add a boolean. What do you call this? Boolean. Like a boolean display. I think we can add this. Excuse me. Or actually, uh, create indicator. There. Yeah. Okay. I think we solved it. I believe. Okay. Uh, uh, okay. No VIs with errors. So I believe we solved it. So the three parts that we modified is this one. The constant pipe is not connected with a wire on the divide. This current temperature was a control before, so we just changed it into an indicator, and this one was previously a string indicator, but now we change it to boolean indicator. So let's try running this one. Okay. In range, no. So let's make this 100. Yeah, okay. In range, yes. Let's see if we can continuously run. See. Okay. In range. So, but if we change it to 10 from 0 degrees to 0 degrees Celsius to 10 degrees Celsius, then it says no. So I think we solved the first part. So, okay. Okay, so continuing to our next part, which is the we solve this one, the debugging part. These three errors is said right here. Okay, we fix that. And okay, runtime error. So let's open the file right here. Incorrect behavior. So okay, unexpected and incorrect responses, and there is a condition expect. So these are the tools that we should use. So it's highlighting probes, breakpoints, and single stepping. So from the project for a window, open analyze temperature incorrect EI, and block diagram set thermocouple to PCI 622A. So let's wait for the program to open. Let me just pause the record. Okay, now so we have this one. So let me just open them here. So set thermocouple channel to 108. Okay. Set thermocouple channel to PCI A1 so instead of A0. Let's how do we change this? Advanced customize A1 then will it work? Let's see. Okay, so this is different one. So let's say okay, yeah, there A1. So from step 2, they get returns at temperature degrees Celsius to corresponding indicator. So calculate the correct environment what should be. Okay, so we can do that. So let's try running this. So we have here our 49.4819. So let's see. I think we just use an online calculator. So let me just copy this. Uh, so Celsius to Fahrenheit. So there must be something that's wrong. So if we paste this one, so it should be 121 degrees Fahrenheit. So if that's the problem, so the current temperature right here. So we have here our thermocouple channel. So what? Let me just see what type of uh, function is this. So this is the uh, create. Okay, create virtual channel. So to add the task, this is the start. Okay, this is okay. So degrees. So degrees C. So degrees C times 9 over 5. So I believe we must rewire this. How do we delete this one? So this one will be connected right here. This one. So should be added, and this one should be right here. Ah, okay. So there's too much going on. What? But okay. Okay, let's do that again. So let's move this up. It's a good thing that we have this one formula right here. So this one should be connected. So 9 over 5. So the output of it should be added, and this one should be right here. Okay, so let's run this one again. Upgrade limit. So okay, so there's an error. So that's output. So let's see. So 9 over 5. Oh, because it's 5 over 9, so this one should be inverted. Okay, let's try. Okay, there. So we solved it. So 1 to 1.067, and if you look up to our 1 to 1.067, and just for measuring, so notice that the VI runs the incorrect result, so we accumulated that. Complete the following steps to identify see the debugging tools and correct the error. Animate the flow of data through the block diagram. Okay, so we didn't perform this, but we'll try this one. So switch to the block diagram and click highlight execution enable and then run the VI. So actually, let's just undo everything. Oh, okay, so since we already know the answer is, let's just follow this one. So, okay, so animate the flow of data, okay, turn on the light bulb, and then run the VI. So, okay. Uh, okay, okay, so with that flow, we notice that the input, the current temperature degrees in Celsius is working properly as expected, but it's in this part that we're having errors. So it is in the problem of converting. So we can already isolate which part of the system is incorrect. So it's this whole part right here. So the in range is still true, so we do not need to worry about this. So it's the conversion pattern here with the numeric functions. So notice that. Okay, so probe the wires, add probe to the wires as shown with figure right by right click. I'm not sure. Where's the probe wires? Probe watch windows. So we need to probe, right click, probe. Okay. So let's add. So let's probe. Am I doing this right? So let's see. So it's 1, 2, 3, 4. Okay, I am doing it now. So let's do that again. Uh, yes, let's look at all the probes. So first we probe the input. Probe right here. Okay, so probe right here. Probe right here. And probe right here. Okay, so we do that. So run the VI. Notice that Windows will label. Oh, yeah. So let's do that. So let's run. Okay. Okay, so we arrived at the same value as seen in this part right here. So we examining this flows, we determine that probe one is also correct, so which we already know. Correct temperature. Probe 4 shows that there's an incorrect. So this means that the mistake is between probe 1 and probe 4. So 1, 2, 3 might be the problem. Or maybe it's already in probe 4. It's possible. So what is the mistake? So remove all the probes by right clicking each probe in the right window and select remove. So remove, remove, remove. Actually, you can just and remove. Okay, so we remove that. So debug the VI using the single stepping code with execution highlighting it slows down. Single stepping. So it's this one right here. Okay, step over. Okay, so we are slowly stepping similar to how excuse me, Visual Studio debug. So click step over button. So we start through the entire block diagram. You suddenly click button to turn on the execution process to the next node. So when you step over the last node, it flashes to indicate it flashes to indicate nodes now. Click the finish VI analyze temperature. Pick the finish VI analyze temperature. Finish run. Block. Step. Okay. So the data flows in two ways, in the indicator and into the multiplication, and it flows to the division. And the good thing right here is we get to see the resulting values. So with that, and then go for error handle. Okay, so in summary, the last one, it has to indicate all logs skipping. So click finish BI. So where do we click finish BI? Is it this one? No, it's not. Set a breaking point to pause the BI and vision. We're looking for Kurang, may have an idea of general department system focus in this area. You can add the breakpoint possibly VI and specify the program. Imagine that you have to try this VI scores at the add function exists. So right click the add function and select the add function. Where is it? Reorder, distribute, retain, CPE1, finish add, no, CRS. No, where can we see the breakpoint? So right click the add function. Alright. Ah, resident. Okay. In the add function, okay. And let's put a set breakpoint. Uh, I think we can close this one. Breakpoint clear. So let's set breakpoint. So set breakpoint right there. Set breakpoint. Notice that the add function is highlighted red now. Corresponds to the right click on the highlighted function and then select breakpoint and then select breakpoint manager. Oh, okay. So we see this. So turn off the highlight execution and turn off the highlight execution and run the program immediately. And notice that it pauses on the part right here. So let's run. Okay, so it immediately stops right here and it did not step by step until it goes that. So now that the VI has reached the area you want to examine, you can start using your debug tools. For example, you turn on highlight execution and click step over button to start single stepping through the VI. So let's turn this on. And single step and it goes right here. And the next part right here is it will go to the QMX right here, the clear task, and then it error handles. Okay, so when finished, remove the breakpoint, right clicking the breakpoint on the black tag and selecting the grade. Okay, so we've already done that, so we can close that one and clear the breakpoint. Okay, if you select disable, the breakpoint will remain not blocked but it will no longer cause the execution. Then you can right click and enable that. So CTV and screenshot the front panel of the black line. So okay, okay. Hmm. So we already saw the mistake. So just to correct everything else, we can just stop this one. Just follow this formula. So let's just delete some of the virus right here because it is incorrectly connected. Okay, so let's put this one. So it should be create constant 9, create constant 5, and select this one. So it should be right here, and so it should be right here. So if we run this, okay, now we reach at the correct output. So that's it for me. For my, let's just stop this one. So step finish block diagram and let's stop now. So let's it for me. So I think we already covered everything. So we can breakpoint use breakpoint manager for specific. Uh, rather for the functions that we want to assess. So you're trying to ensure that the functions are correct. So I think the Pro Watch window is also the same, but for the Pro, it focuses more on the output that the function provided. So if the problem is the output, if you think the problem is output, so we can use Pro Watch window because we can see the results. So maybe there's a misaligned or incorrect wiring. But for the functions, I believe you can work both of these. So that's just how I view things. So this one is usually uh, for the step by step. So because this one offers step by step flow, whereas to Pro you see the values right here. And of course, the highlight execution is also really helpful. So I think that's it for me. We perform execution highlighting, probing, breakpoints, and single step. So I think that's it for me. So this is for my laboratory 7 and thank you very much.